তোমাদের লাস্ট কতটা হয়েছিল ওই HWM এ?
হ্যালো স্যার।
হ্যাঁ, তোমাদের HWM এ ওই লাস্ট ইউনিট ডিজাইনটা হয়েছিল তাই তো?
হ্যাঁ হ্যাঁ, ওই HTU NTU এসবগুলো করেছিলাম, মানে অঙ্কটা হয়েছিল।
ওটা
হুম হুম।
নিউমেরিক্যালটা লাস্ট হয়েছিল তাই তো?
হ্যাঁ হ্যাঁ, মেডিকেল হয়ে গেছিল। হুম।
Okay. তাহলে আজকে আমরা করবো ফার্স্ট, আজকে টুডে উই উইল ডিসকাস দ্য সেকেন্ড operation or second process of hazardous waste management, that is chemical oxidation. Okay, so last day we have completed the air stripping method. Today we will start with chemical oxidation. In chemical oxidation we can detoxify some of the problematic compound of any waste, where we'll basically add some oxidizing agent, okay, which will transform a particular targeted compound or component. Say a particular compound is A, which is the problematic compound in a waste, and we are targeting this compound. We want to convert this toxic compound or toxic chemicals to a non-toxic one, or we want to simply detoxify the waste. So what we will do here? Here we will add a chemical oxidizing agent, which will oxidized this chemical compound A to some intermediate compounds, and say carbon dioxide and water. Some intermediate compounds and carbon dioxide and water. So say it will be converted to plus an intermediate compound. An intermediate compound I, that will be generated. Now that intermediate compound may be less toxic than the original. However, this intermediate compound may be also amenable to further treatments, like either we can treat this compound by biological method, or further chemical treatment, by which it will be converted to a non-toxic compound. Okay, so chemical oxidation can be used to basically completely destroy a wide range of toxic organic compounds, okay, including chlorinated VOCs. Fluorinated VOCs can be the example, of such type of toxic compounds. Okay, so this chlorinated VOCs we can basically oxidize them and we can convert them to some non-toxic waste. That can be done by chemical oxidation. Also, we can use this for markup. Okay, and inorganic like cyanides. For inorganic like cyanides also can be chemically oxidized and can be converted to some non-toxic compounds, or we can say we can detoxify them. Okay, so that's how we will use the chemical oxidation in treating hazardous waste. Okay, now in case of hazardous waste treatment, there are several type of oxidizing agents that we can use. The oxidizing agent which we will use in hazardous waste management can be different types. Very common type is known as chlorine. We know we use this chlorine also in our normal water treatment process. Then ozone can be used, and then H2O2 or hydrogen peroxide also can be used. Okay. Normally UV light is also supplied with this chemical oxidants, that means with chlorine, ozone or H2O2. Along with them some UV lights also will be supplied to accelerate the oxidation of specifically fluorinated VOCs. When fluorinated, fluorinated VOCs sort of waste will be there, not only the oxidizing agent like chlorine, ozone or hydrogen peroxide, but along with them some UV light also will be supplied, which will accelerate the oxidation process. Now, generally we know that whenever any reaction will happen, that normally happens in a redox reaction. The reaction happens normally is a redox reaction. That means oxidation as well as reduction, both the operation will be there. Okay, like here, suppose this oxidizing agent is oxidizing this A to either CO2 or say IC. Oxidizing agent is oxidizing compound A, so it itself get reduced to some other forms, right? অক্সিডাইজিং এজেন্টটা এ কে অক্সিডাইজ করবে, তার মানে ও নিজে রিডিউসড হবে। So here oxidizing agent will act as a oxidizing agent which will oxidize the compound A, and compound A will act as a reducing agent which will reduce the other reaction. So here both the reaction will happen. One reaction will be oxidation, another reaction will be reduction. Okay, the waste compound which is oxidized by the oxidizing agent will serve as a reducing agent. That is the one common point. That means oxidation and reduction, both the reaction will happen together. Now oxidizing agents are non-specific. That means whatever reagent you are using, either chlorine or ozone or H2O2, it is non-specific. What is the meaning of non-specific? তার মানে আমরা যে কম্পাউন্ডটাকে টার্গেট করছি ওনলি সেটাই রিমুভ হবে, এটা হবে না, সেটা ওটার সাথে সাথে আরো অনেক জিনিসকে অক্সিডাইজ করতে পারে। সাপোজ ইউ আর অ্যাডিং সাম ক্লোরিন অর ওজন অর H2O2, it will not only oxidize the targeted compound. Suppose you want to target the cyanide present in water, right? You want to target the cyanide present in water, and for that reason suppose you are adding ozone or something else. Now this ozone not only oxidize the cyanide compound, but it can also oxidize some other organic compounds or other reduced form of any other compounds. It will oxidize them also. So it is a non-specific one. It will not target the simply cyanide only. Okay. So as it is a oxidizing agent, it will normally oxidize the other compounds present in the water also. Okay. So for that reason, obviously it will be economical as well as it will be its efficiency will be more if the other compounds present in the water is in very less quantity. Okay, if they will present in very large quantities, then this oxidation operation will not be that much fruitful, because most of the reagent you are adding, most of the portion of that reagent will be used to oxidize the other compound, because other compounds are present in that water. So suppose if you are treating or if you want to target a particular compound, make sure that other than that compound other waste are present in very less quantity. অর্থাৎ সায়ানাইডকে যদি টার্গেট করছো তাহলে সায়ানাইড ছাড়া বাকি যে অর্গানিক কম্পাউন্ডস বা বাকি যে রিডিউসড ফর্মগুলো থাকবে, যাদেরকে অক্সিডাইজিং এজেন্ট অক্সিডাইজ করে দিতে পারে, সেগুলো যেন খুব লেস কোয়ান্টিটিতে থাকে। ওকে, ইজ দ্যাট ক্লিয়ার? তাছাড়া কি হবে, we have to use this oxidizing agent in very large quantity. Okay, now if other waste or other organic compounds are present in large quantity, what will be the problem? First problem is that you need the excessive amount of the oxidizing agent, right? So huge quantity of the oxidizing agent is required. Not only that, some organic compounds like say HC, hydrocarbon, and suppose you are adding chlorine as your oxidizing agent. So at that time, what will happen? Chlorine even can convert this hydrocarbon, resulting in chlorine substituted sorry, chlorine substitution will happen, and you will get some chlorinated hydrocarbon, okay, or chlorinated organic material. So ultimately that will result in generation of some toxic chlorinated hydrocarbon, okay. So that will be again, you have to remove that one by some method. So obviously that will be problematic. For that reason, always make sure that the other organic compounds or other uh, any type of waste which will get oxidized if you add some oxidizing agent, those sort of waste should not be present in that water or should be less in the quantity. The, the compound you are targeting, other than that compound, the other compounds must be in very less in concentration or in quantity. Okay. Now we will describe the process. So how this chemical oxidation will happen. So chemical oxidation, as we have understand what will be in the process, will be normally done in a completely mixed flow reactor. This sort of say reactor will be there, right? Okay. Now suppose water is entering or anything is entering like this, either you can give your dose here, either in this portion from where the water or from where the waste is entering, either you can add the oxidant here, either you can add your oxidant here, and following the addition of the oxidizing agent, following the addition of oxidizing agent, what you can do, either with the help of the baffle or with the help of the bubble aerators, you can completely mix this waste and this oxidizing agent so that there will be a homogeneous mix, right? So either this oxidizing agent will be injected into the contaminated water in the channel where from it is entering, or directly in the tank also you can charge the oxidizing agent. But make sure there will be a complete mixed region, and for that reason either you have to use some mechanical agitation like this or some bubble aerator sort of things. So you have to use this sort of things. Okay, is this clear? Then you have to allow for some time, some detention time, and finally from the other side the water will coming out, where you will get that compound will not be present, which is your targeted compound, or your targeted compound will present in a very less quantity. So that will be your target. Okay. Now we will study in details about the chemical oxidation of some compound. Say first we will go through the chemical oxidation by chlorine itself. So by chlorine, chemical oxidation by chlorine. Now we know that chlorine is a dense gas that normally readily liquefies under pressure. Okay. So normally what happened in any industry or where your chlorine you are using, that will be stored in a cylindrical gas cylinder like this. Okay. where you have a high amount of pressure applied. So chlorine gas, when you have applied lots of amount of pressure, that will be transferred to liquid. That means the tank, the cylinder you will get, there will get basically the chlorine liquid is present there. Now when you will open the stopcock of that cylinder, that chlorine liquid will get transferred to chlorine gas. Okay, Cl2 gas. Why it is transferred to chlorine gas? Because it is open to the, or it is under the atmospheric pressure. Here it is under the huge pressure. When you are applying huge amount of pressure in the chlorine, that will be readily converted to liquid. But when you just apply the atmospheric pressure, it will be converted back to the gaseous form. And by the gaseous form, it will flow through the tubes or through the pipes, and ultimately, say this is the water pipe or the waste pipe, and you are injecting the chlorine gas here, right? So chlorine gas as a gas will transfer and will be injected at some point in the waste. So there, what will happen? Chlorine gas will be converted to chlorine aqueous solution, right? What is the meaning of chlorine aqueous solution? That means chlorine will react with the water. By reacting with the water, it will form HOCl plus HCl. We know this, right? Now this HOCl further dissociate and form H plus OCl. Now this first reaction will not happen if pH is less than 5. So this chlorination process is very much pH dependent, and we know that the chlorine will not dissociate in the water if its pH is less than 5. So its pH should be more than 5. And if its pH is more than 7.5, the predominant form of free chlorine will be the OCl minus. So OCl minus will be present in the majority if the pH is greater than 7.5. Okay. In market, we know some of the chlorines is also available in solid form. In sometimes in our toilet or kitchen we use bleaching powder, right? So that is the solid form of chlorine. That is basically sometimes we use the calcium hypochlorite form also. That means CaOCl whole 2. This is available in the market also, or dry calcium hypochlorite also we can purchase, right? Now as I am telling you that once chlorine is in the aqueous solution and its pH is greater than 7.5, the predominant form will be OCl minus. Okay. Now we'll get some example how chlorine will treat any hazardous compound. So let us go through the example of cyanide. Okay. So destruction of cyanide will now listen, or will now go through destruction of cyanide by chlorine. So destruction of cyanide. So destruction of cyanide by chlorine is the classic example of destruction of cyanide by any oxidizing agent. Okay. So under alkaline condition, cyanide is oxidized by hypochlorite ions. Okay. As I have told you, once you are having pH greater than 7.5, major of the form will be OCl minus. So under alkali condition, cyanide will be oxidized by the hypochlorite ions to some less toxic compound called cyanate. So it will be oxidized to cyanate. Oxidation will happen. Okay. However, you have to take the necessary precaution to maintain the pH above 10. Why we are maintaining the pH above 10? So that no further toxic gas called cyanogen chloride will be generated. CnCl, cyanogen chloride. So Cl, a pH greater than 7.5, OCl minus only will be there, but still you have to maintain a pH of uh, greater than pH above 10, so that no cyanogen gas is generated, because if the pH is less than 10, then sometimes cyanogen chloride gas is generated. Okay, so cyanide means essentially Cn minus. Anything called Cn minus will be there. So any Cn minus, if it is present in the water, and if you are using chlorine in the water, and if it is transferred to hypochlorite ion, it will be like this: Cn minus plus OCl minus. Okay, the Cn minus plus OCl minus, it will be generally converted to CnO. So from Cn to CnO, there is this oxidation, right? Oxidation is happening, and plus Cl minus, OCl minus to Cl minus. Now, if NaCN is present, Cn can be of different compound, either NaCN or any other Cn can be there. If NaCN is present, and if you are using chlorine, then CnCl can generate plus NaCl can generate if the pH is less than 10. If the greater than 10, this will not happen. So under caustic condition, this hydrogen chloride will be converted. So if you make pH greater than 10, this CnCl will not be present in the water. But if pH is less than 10, this CnCl will be present in the water or can be generated in the water. This is the gaseous form, this CnCl. Okay? So this CnCl is a gaseous form. This will generate if the pH is less than 10. But if the pH is more than 10, under caustic condition, this cyanogen chloride will get converted to sodium cyanide. So what will happen? This CnCl under caustic condition, that means when the pH is greater than 10, NaOH with NaOH or with OH minus, it will react and it will form NaCnO plus H2O plus NaCl. So this cyanide can be completely detoxified or destroyed by further addition of caustic soda along with the chloride, along with the chlorine. So if you go to this NaCnO, you can make a reaction. If NaCnO along with this NaCnO, you are further adding NaOH and Cl2. So if you further make the condition caustic, you will add the caustic or NaOH, and along with that if you add the chlorine, so that NaCnO will be further oxidized, okay, or further detoxified, and it will form N2 plus CO2 plus 6 NaCl plus 2H2. So all of them are normal compound which does not have any toxicity. Okay. So for that reason, you don't calculate your chlorine requirement based on this only, but rather you add excess chlorine. You add excess chlorine so that to ensure that the cyanogen chlorine is not produced. That is, CnCl is not produced. CnCl is get converted to NaCnO and it further get converted to into CO2, NaCl and H2O. So in practice, when you will do the destruction of cyanide by chlorination, you will add excess amount of chlorine that is added so that you make sure that no cyanogen chloride or cyanogen chlorine will get produced. Okay. So actual amount of chlorine dosing will depend on the other constituent also of the water. If the water say contains some excess metals or some excess reducing agent, any metals is also a reducing agent or any other reducing agent, if it is present in your water, they will react along with the chlorine. Okay. Either they will form like MCl, MCl2, MCl3 like this if it is a metal, or RX, the reducing agent, also will combine with the chlorine. Okay. So obviously if they will present the your chlorine demand or chlorine you want to add will be higher. Okay. Otherwise stoichiometrically calculated chlorine will not be enough, because all these reducing agent and metals are present in your water, they will also react with the chlorine. Okay. So for that reason additional chlorine you have to add. But whether those are problematic? No. Additional chlorine is not stable in the aqueous solution and will be lost in decomposition. Okay. So if cyanide is present in the form, and there if you have say iron and nickel compounds, or say cyanides are present as a complex of iron and nickel like this, say Fe cyanide, this is present. So if we normally, if it is 2 plus, cyanide is 1 minus. So 6 into 1 minus is 6 minus, and this is 2 plus, so ultimate charge will be 4 minus. So suppose if he is present like ferrocyanide, like this one. Sorry, cyanide is present like this, ferrocyanide. So if cyanide is present like a complex of iron and nickel, then destruction of cyanide by chlorine is more difficult. It is more difficult to oxidize this ferrocyanide. Okay. So what you will do? You have to first, if you add the chlorine, it will be first get converted to 3 minus, efficiency 3 minus. Okay. So ferrocyanide to ferricyanide it will be first converted. FeCN6 3 minus. Here the charge of Fe is P plus. So here the oxidation is happening. 3 plus to, sorry, 2 plus to 3 plus. Iron is oxidized only. Okay. So ferrocyanide is converted to ferricyanide. Okay. Now, if it is converted to ferricyanide, any further destruction by chlorine is ineffective. If you add further chlorine, it will be ineffective. Okay. For nickel and excess doses of chlorine of approximately 20%, you have to add. So those will be the reason, those will be the amount you have to add. Is it clear? এখানে কারো কোনো কনফিউশন আছে এতদূর অবধি? হ্যালো, ঠিক আছে, বোঝা গেছে তো? তাহলে এরপর আমরা এটা নিউমেরিক্যালস করব। So now we'll do the numericals based on this oxidation of cyanide by chlorine. Our first problem. Write down the problem. A waste stream of 20,000 gallon per day contains 270 milligram per liter cyanide. Add sodium cyanide. Add sodium cyanide. Determine the theoretical amount of chlorine required daily to destroy this waste. Required daily to destroy this waste. তাহলে কি বলেছে, একটা ওয়েস্ট স্ট্রিমের ফ্লো বলে দিয়েছে, কনসেন্ট্রেশন বলে দিয়েছে সায়ানাইডের। সো থিওরিটিক্যাল ক্যালকুলেশন মিন্স stoichiometrically you have to calculate how much chlorine will be required. So we will use our equation, so you have to remember the equation for doing this problem. Okay, so now first we will calculate how much, what is the mass of NaCN discharged daily. What is the mass of NaCN discharged daily? What is the flow? That is 20,000. প্রবলেমটা সবার লেখা লেখা হয়েছে তো? Okay, yes, nearly 20.439. No, 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 no. 20,439 gram per day. Okay, so 20,000 is gallon. Now 20,000 is your gallon. Now you want to convert this gallon to liter. So that will be 3.7854 nearly. That much liter per gallon. So this much is the liter. Now if you want to convert this liter to meter cube, then it will be multiplied by 10 to the power minus 3. So that much meter cube per day is the flow. Now what is your concentration? 270 milligram per liter. Milligram per liter is as good as gram per meter cube. It will be same. So we will multiply by 270. So that much gram per day will be there. Okay. Now calculate how much it is coming. 20 পয়েন্ট হবে না, এটা 20,441 বা 439 এরকম হবে, দেখো। হ্যাঁ, this much gram per day. Okay, now gram per day. Now we have calculated how much gram per day of NaCN is present, but how much gram mole of NaCN is present or discharged daily, that you have to calculate. So gram mole of NaCN discharged daily. That will be how much? 20439, that much gram is discharged daily. Now what is the molecular weight of NaCN? How much is the Na? Na কত? Na কত? কার্বন কত আর নাইট্রোজেন কত? Carbon is 12, Na is 23, okay, and nitrogen is 14. Clear? So how much is the molecular weight of NaCN? It is 49. 23 plus 12 plus 14, so 49. So if 49 gram means 1 mole, so 20439 means how much gram mole? That will be divided by 49. So that much gram mole is present or is discharged daily. So this will come as, calculate কত আসছে?
417.
417, that much gram mole, right? Now we'll write down the equation how much Cl2 is required. So if your NaCl is say 2 plus 2Cl2, then it will be converted to 2 NaCl plus 2 CnCl. This is equation number 1. Now You want to convert this CnCl also. So 2CnCl plus 2Na, 4NaOH will be get converted to 2NaCnO plus 2H2O plus 4NaCl. That is equation number 2. Now this NaCnO again you want to convert, right? So NaCnO reaction টা কি লিখেছিলাম? 2NaCnO plus 3Cl2, right? 2NaCnO plus 3Cl2 plus 4NaOH will get converted to nitrogen plus carbon dioxide plus 6NaCl plus 2H2. So the reaction will happen in this three stage. Now add all these three. So what will happen? You check. So this, when you will add these two, these sides, obviously 2NaCnO will cancel each out other. 2CnCl will cancel out. Okay. Now add this two. So what will happen? 2NaCn plus 2Cl2 plus 3Cl2. So it will be 5Cl2 plus 4NaOH plus 4NaOH. So 8NaOH will get converted to 2NaCl plus 6NaCl. So plus 4NaCl. So 6 to 8 and 4. 12NaCl plus 2H2O plus 2H2O. 4H2O plus N2 plus CO2. So sorry, CO2. So this will be your complete reaction, right? So we understand that for 2 mole of NaCl, 5 mole of Cl2 is required. So for 1 mole, how much is required? For 1 mole, 2.5 mole is required. Now how much gram mole of NaCl is discharged? 417. So how much mole of chlorine is required? So daily chlorine requirement will be 417 into 2.5. Is that clear? এটা কি বোঝা যাচ্ছে? ওকে, আচ্ছা আচ্ছা, হ্যাঁ স্যার বলুন। হ্যাঁ, ঠিক আছে, ওকে। হ্যালো, হ্যাঁ বলুন। হুম 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 হুম, আচ্ছা আচ্ছা, ফার্স্ট আপনাকে যেটা করতে হবে, একটা মেল লিখে দিতে হবে, আমার মেল আইডিতে একটা মেল করে দেবেন উইথ দ্য আর্কিটেকচারাল প্ল্যান, ঠিক আছে? aroy.civil, aroy, AROY dot civil @jadavpur university dot in। আপনার এই নাম্বারে কি হোয়াটসঅ্যাপ আছে? তাহলে আমি আমার কার্ডটা পাঠিয়ে দিচ্ছি। হ্যাঁ হ্যাঁ, আমি একটু ক্লাসের মধ্যে রয়েছে, আমি একটু পরে পাঠাচ্ছি, ঠিক আছে? ওই 12টা নাগাদ আপনাকে পাঠিয়ে দিচ্ছি। ওখানে আপনি একটা মেইল লিখবেন যে এই এর জন্য মানে আপনাদের বেস্ট রেট কোটেশন পাঠাতে, রেটিং এর জন্য। এটা ডিজাইন এবং ড্রয়িং ডকুমেন্টস আপনাদেরকে পরে সাপ্লাই করতে হবে। ইনিশিয়ালি আপনাকে যেটা সাপ্লাই করতে হবে সেটা হচ্ছে আপনার আর্কিটেকচারাল প্ল্যান, ঠিক আছে? মানে যেটা দেখে হ্যাঁ, যেটা যেটা মানে আপনার প্ল্যান ভিউ এবং এলিভেশন ভিউ দুটোই থাকবে, মানে যেটা দিয়ে বেসিক্যালি এরিয়াটা ক্যালকুলেট হবে আর কি, বুঝতে পারছেন? তো হ্যাঁ হ্যাঁ, ওটা আপনি পাঠিয়ে দিন। ওটাকে পাঠিয়ে দেওয়ার পরে আমরা তার একটা বেস্ট রেট কোটেশন পাঠাই এবং অ্যালং উইথ আপনাদেরকে কি কি ডকুমেন্ট সাবমিট করতে হবে সেটা পাঠিয়ে দেবো, ঠিক আছে? হ্যাঁ 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 হ্যাঁ, ওটা তো ওই আপনি অ্যাকচুয়ালি দেখুন, ওটাকে ফাইনালি দেখে বলতে হবে, কারণ অনেক সময় অনেক বিল্ডিং ছোট ওভারঅল এরিয়া হতে পারে, কিন্তু ধরুন অনেক কমপ্লিকেশন থাকে, সেই জিনিসটাকে দেখে নিতে হবে। নর্মালি বড় কাজ হলে একটু কম বেশি হয়, তাছাড়া 1.75 এই পার স্কয়ার ফিটে করা হয়, বুঝতে পেরেছেন? হ্যাঁ, এবারে বড় হলে ধরুন একটু কম বেশি হলে সেটা একটা আলাদা ব্যাপার, বুঝতে পেরেছেন? ঠিক আছে, মেলে আপনি জাস্ট এটা আমাদের আর্কিটেকচারাল প্ল্যান, এটার রেটিং এর জন্য আহ, আপনাদের বেস্ট রেট করেছে এই হলো। হুম, 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 হুম। হ্যাঁ, 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 এটা কোটেশন পাঠানোর জন্য এটাতেই হবে। তারপরে আপনি যখন মানে রেটিং এর জন্য তো আপনাকে ডিজাইন ডকুমেন্ট এন্ড ড্রয়িংটা পাঠাতে হবে, বুঝতে পেরেছেন? আচ্ছা, সেটা আপনাকে আমি একটু পরে ফোন করি, কারণ আমি একটা ক্লাসের মধ্যে আছি, তো তাহলে আমি এটা কল ব্যাক করছি, ঠিক আছে? ওকে, হ্যালো, হ্যালো,
Yes, sir.
হ্যাঁ, সরি। তো তাহলে ফর 1 গ্রাম মোল অফ NaCl, 2.5 mole of gram mole of Cl2 is required. So for 417 gram mole, how much Cl2 is required? So Cl2 daily Cl2 requirement will be daily chlorine requirement will be how much? 2.45 into that 417 gram mole, right? So 2.5 into 417, that much gram mole per day, or daily you have written, so you can omit the per day also. So daily requirement will be this much. So this is gram mole of CO2. This much gram mole of CO2 is required. Now what is the molecular weight of CO2? You will multiply that one. So Cl2, you will consider gram molecular weight as 2 into 35.45, right? 2 isotope is present, that's why we take the average of 35.45. So 2 into 35.45, so that much. 2 into 35.45, that much gram per day is required. So calculate how much gram per day is coming.
Yes, 73,934.
73,900, about 13.25. This one. Okay, if this is the gram per day, then you can write in kg per day how much is required. That is 73.9 kg per day. Yeah, right. So this will be your daily chlorine requirement. সবার বোঝা গেছে প্রবলেমটা? কিছুই নেই, জাস্ট স্টয়চিওমেট্রিক্যালি ইকুয়েশনটা মনে রাখতে হবে, তারপর বাকিটা স্টয়চিওমেট্রিক্যালি ক্যালকুলেট করে নিতে পারবো। ওকে, নাও সেকেন্ড প্রবলেম, এটা সবার হয়েছে তো? সেকেন্ড প্রবলেমে যাচ্ছি তাহলে।
Yes, sir.
ওকে, প্রবলেম 2. So write down the problem statement first. A waste stream contains 85 kg of cyanide daily. So a waste stream contains 85 kg of cyanide daily. Determine the stoichiometric amount of chlorine. Determine the stoichiometric amount of chlorine and caustic soda required to oxidize required to oxidize. First step, that is first problem, that is cyanide to cyanate. Cyanate. Second step is oxidize cyanate completely. Oxide, oxide cyanide, oxide cyanide completely. Oxidized cyanide completely to nitrogen. Disregard the caustic soda requirement. Disregard কি হলো বুঝছো তোমরা লিখেছো প্রবলেমটা
তো
ওকে
কি
সেকেন্ড স্টেপটা লেখো oxidized cyanide completely to nitrogen.
রাখতে
Oxidized cyanide completely to nitrogen. Disregard the caustic soda requirement. Disregard the caustic soda requirement. For maintaining pH equals to 10. For maintaining pH equals to 10.
সরি স্যার সেকেন্ডটা আরেকবার বলবেন
হ্যাঁ সেকেন্ড ডেটটা
অক্সিডাইজ সায়ানাইড
cyanide
কমপ্লিটলি টু
completely
তারপর
nitrogen. Disregard the caustic soda requirement. For maintaining pH equals to 10. pH equals to 10 করার জন্য caustic সোডার যে এক্সট্রা রিকোয়ারমেন্ট সেটাকে বাদ দিয়ে ক্যালকুলেট করতে হবে মানে জাস্ট ইকুয়েশন গুলো দিয়ে যতটা ক্যালকুলেশন আসবে সেটুকুই আমাদের যে পিএইচটা 10 মেনটেন করতে হবে তার জন্য তো কিছু caustic সোডা লাগবে সেইটাকে ক্যালকুলেট করতে বারণ করা হয়েছে এটুকুই আর কিছু না ঠিক আছে ক্লিয়ার
Yes, sir.
সো ফার্স্ট স্টেপ অফ দ্য প্রবলেম আমরা করছি that is oxidation of cyanide to cyanate. Cyanide to cyanate. তাহলে ফার্স্ট কি হবে আমরা জানি chlorine will react with water to form HOCl plus H plus plus Cl minus. HOCl will form H plus plus OCl minus. Now Cn will react with OCl minus to form CnO plus Cl minus. So in this way your total equation will become Cl2 plus Cn plus H2O and it will become 2H plus plus 2Cl minus plus CnO minus. So this implies that 1 mole of cyanide requires 1 mole of chlorine, right? এখানে দেখো 1 mole cyanide requires 1 mole chlorine, right? তাহলে 1 mole cyanide এর জন্য 1 mole chlorine লাগছে. Now how much Cn minus contains in the waste stream? Cn minus contains in the waste stream সেটা কত সেটা হচ্ছে 85 kg 85 kg means 85 into 10 to the power 3 gram or how much mole 85 into 10 to the power 3 by what is the molecular weight of Cn minus কত? It is 12 plus 14, so 26. So divide it by 26. So that much gram mole of CN. So calculate কত গ্রাম মোল আসছে? কত গ্রাম মোল আসছে ক্যালকুলেট করো।
So 3269.23.
3269.23. That much gram mole of CN. তাহলে এত গ্রাম মোল অফ CN দরকার হলে Cl2 কতটা দরকার হবে? Cl2 required will be how much? সিম্পল 1 মোলের জন্য 1 গ্রাম মোলের জন্য 1 গ্রাম মোল, সো 3269.23 গ্রাম মোলই রিকোয়ার্ড হবে, রাইট? এত গ্রাম মোল মানে কত গ্রাম অফ ক্লোরিন? So that will be simple 3269.23 into 2 into 35.45, that much gram. তো সেটা কত আসছে দেখো, 32.3269.23 into 2 into 35.45, তো আসছে হচ্ছে 231.78 কেজি। So এতটা first step এ chlorine requirement. And what is the NaOH requirement? NaOH required will be 0. See, in the first step, in the equation, you don't require any NaOH, right? So NaOH required will be 0 and Cl2 required is 231.78 kg. First step to solve হয়ে গেছে, cyanide to cyanate, this is done, right? এটা হয়ে গেছে?
Yes, sir.
Okay. Now we'll calculate the cyanide, oxidation of cyanide to nitrogen completely. So now the second step. In the second step, so NaCnO plus 3Cl2 plus 4NaOH is converted to N2 plus 2CO2 plus 6NaCl plus 2H2O. So this equation implies that 1.5 mole of chlorine is required per mole of CNO, because you know 3 mole is required for 2 mole of NaCNO. So 1.5 is required for 1 mole of NaCNO. Now 1 gram mole of Cn minus is equivalent to 1 gram mole of CnO minus, because I am talking about the 1 gram mole of CnO minus, 1 gram mole of Cn is equivalent to 1 gram of CnO minus. That means 26 gram of cyanide is equivalent to 42 gram of CnO. কেন? এই 42 গ্রাম অফ CnO এর মধ্যে 26 গ্রাম CN ই আছে, রাইট? So 1 gram of CN is equivalent to 42 by 26 gram of CnO. Now 1 kg of CN, sorry, CN is equivalent to 42 by 26 kg of CnO. Now আমাদের কতটা ওয়েস্ট স্ট্রিমে আছে বলা হয়েছে 85 কেজি CN, রাইট? 85 কেজি সায়ানাইড আছে। So 85 kg of CN minus means how much kg? 42 by 26 into 85, this much kg of CNO. তাহলে আমি ফার্স্টে 85 কেজি সায়ানাইড মানে কতটা CNO সেটা বের করে নিচ্ছি। তাহলে সেটা বের করো, কত কেজি CNO? কত আসছে দেখো?
So 137.3.
তাহলে 137.31 kg of CNO minus. Now এখানে আমাকে দিয়ে দেওয়া আছে কি NaCNO। তো আমি বলতে পারি 1 মোল NaCNO তে 1 মোল CNO আছে, রাইট? তো 1 মোল NaCNO এর জন্য কতটা Cl2 দরকার? 1.5 মোল অফ Cl2। So for 1 mole of NaCNO, 1.5 mole of chlorine is required। কিন্তু 1 মোল NaCNO মানেই তার মধ্যে আছে 1 মোল অফ CNO মাইনাস, সো তার জন্যও লাগবে 1.5 মোল অফ Cl2, রাইট? নাও 1 মোল CNO মানে কি? 42 গ্রাম অফ CNO। তো তার জন্য কত লাগবে? 1.5 মোল মানে কত গ্রাম অফ Cl2? 1.5 into 35.45 into 2, that much gram of Cl2, clear? So এখান থেকে পাবো যে 1 গ্রাম অফ CNO জন্য কতটা Cl2 লাগবে, that will be 1.5 into 35.45 into 2, 1.5 into 35.45 into 2 divided by 42, এত গ্রাম Cl2 লাগবে। তাহলে 1 কেজি অফ CNO এর জন্য কত লাগবে? সিমিলারলি 1.5 into 35.45 into 2 by 42 কেজি অফ Cl2 লাগবে। সো 1 কেজি অফ CNO এর জায়গায় এবার আমি যদি 137.31 ইউজ করি, তো 137.31 kg of CNO is required how much amount of Cl2? So that means 1.5 into 35.45 into 2 into 137.31 divided by 42, this much kg of Cl2। তাহলে বের করো কত কেজি Cl2 লাগছে। 347.6, তাই তো? So this much amount of Cl2 is required। Now it is written that how much total Cl2 is required for, sir? হ্যাঁ হ্যাঁ 32, হ্যাঁ হ্যাঁ হ্যাঁ। So now it is written that how much is chlorine required for complete destruction of cyanide. So you write down the total Cl2 required, total chlorine required for complete destruction of cyanide is how much? First step কতটা এসেছিল? First step required chlorine, ফার্স্ট স্টেপে তোমাদের দেখো ফার্স্ট স্টেপে কতটা এসেছিল? 231 বা কিছু একটা এসেছিল দেখো। 231.78। আর সেকেন্ড স্টেপে কত এলো? 347.6। তো এই দুটোকে অ্যাড করতে হবে, তাহলে এতটা হচ্ছে টোটাল ডিস্ট্রাকশনের জন্য দরকার। ফার্স্ট স্টেপে 231, সেকেন্ড স্টেপে হচ্ছে 347, তাহলে টোটাল করো কতটা আসছে? এত কেজি অফ Cl2 পার ডে, 579.38। This much kg of Cl2 is required per day। Okay, now in the second step we will calculate how much NaOH is required। এতদূর অবধি সবার হয়েছে? So how much NaOH is required, that we will calculate। So what is the NaOH required? So we will go to the equation again। So if we can see 1 mole of cyanide, 1 mole of CNO is required 2 mole of NaOH. So for 1 mole of cyanate, you need 2 mole of NaOH, right? So your NaOH requirement will be how much? NaOH requirement will be 2 into the gram mole of cyanate or CNO minus. How much gram mole of cyanate is present? Now we know that 85 kg of CN means how much gram mole of CN minus? We have calculated how much gram mole of CN minus is present. 85 kg means 85 kg of CN means so 3269.23 gram mole of CNO, right? 1 gram 85 kg of CN means 3269 কত ছিল বলো 3269.23 না পয়েন্ট কত ছিল 3269.23 that much gram mole of CNO ছিল তাহলে 2 into এই 3269.23 এত গ্রাম মোল আমার NaOH লাগবে 2 into 3269.23 এত গ্রাম মোল আমার NaOH লাগবে so this much gram mole. Now NaOH you have to convert into gram, so this much gram mole means how much gram? 3269.23 into the molecular weight of NaOH, that will be how much? 23 plus 16 plus 1, so হচ্ছে 40. So we will multiply this by 40. So that much gram of NaOH is required daily per day. So calculate how much gram of NaOH is required or how much kg of NaOH is required. Directly you can calculate. Calculate from here.
Two 261.538 kg.
261.538 kg of NaOH is required. And as there is no other NaOH requirement in the first step, so this will be your total NaOH requirement, where you have not considered the amount of NaOH need to maintain the pH of 10. This is the only requirement only as per the equation. That means only to convert the cyanate to final compound, that is nitrogen and Cl2, right? So this will be the total requirement of NaOH. So এই টাইপের প্রবলেম আসতে পারে এই অক্সিডেশন থেকে, সায়ানাইডের অক্সিডেশন বাই ক্লোরিন থেকে। ওকে, so we'll stop here today. Next day we'll start from the oxidation by ozone, and then we'll discuss some membrane separation process like electrodialysis, microfiltration, ultrafiltration, all this kind of RO, all this kind of technology we'll discuss. Okay. First we'll go through the electrodialysis, that may require 1 day, and then we'll go through the ultrafiltration process, then RO process and all these things. Okay. So
Okay.
we'll stop here today. Next day we'll discuss at first the day, oxidation by ozone, and then we'll go through the electrodialysis process.
Okay, sir.
Okay. সবাই বুঝতে পেরেছো? কার কোনো ডাউট আছে?
একবার একটু চেক করে নি দিয়ে তারপরে নেক্সট দিন নয় বলবো।
ওকে ওকে, জাস্ট কেমিক্যাল ক্যালকুলেশন একটু দেখে নেবে। আহ, ওরকম কিছু মানে প্রসেস ওয়াইজ তো খুব একটা এটাতে কিছু ডিফিকাল্ট কিছু নেই, ক্যালকুলেশন গুলো একটু দেখে নেবে যে গ্রাম মোল, ইকুইভ্যালেন্ট ওয়েট, মলিকুলার ওয়েট, এগুলোর একটা কনসেপচুয়াল ব্যাপার থাকতে পারে। তো জাস্ট জাস্ট ট্রান্সফরমেশন ইকুয়েশন গুলোতে আর কিছু নেই। আর কত মোলের জন্য কত মোল রিকোয়ার্ড হবে সেই ব্যাপারটাকে একটু দেখে নিতে হবে, আর কিছু নেই।
সে
ওকে,
থিওরি কোশ্চেন আসে না না?
এখান থেকে খুব একটা থিওরি আসে না, বাট পরের পার্ট গুলো থেকে আসতে পারে। যেমন ধরো হচ্ছে ওজন দিয়ে ইয়ে
আচ্ছা।
থিওরি আসতে পারে, মানে ক্লোরিন দিয়ে কিভাবে ডিস্ট্রাকশন হচ্ছে সেখান থেকে থিওরি আসতে পারে, বা ধরো ওজন দিয়ে কিভাবে ডিস্ট্রাকশন হচ্ছে, বা আরো ইউএফ, এই পার্ট গুলো থেকে থিওরি আসতে পারে।
ওকে স্যার।
Okay? বেশি প্রবলেমই থাকবে, কিন্তু মানে ধরো 50-র মধ্যে কিছু থিওরি থাকতে পারে। ওকে,
ওকে স্যার।
ঠিক আছে। কে কে প্রেজেন্ট আছো? কতজন আছো? 12 জন? না, 11 জন। আচ্ছা।